Hi everyone, this video we're going to be talking about straight lines and gradients. This is stuff that you will have seen before, so let's go through this quickly. The equation of a straight line, and we talk about the gradient, midpoints, things like that. So we know that the equation of a straight line is y equals mx plus c. We need to understand that m is the gradient and c is the y-intercept. So if I give you an equation of any line, you could quickly be able to see, okay, the gradient of that one there is 2 and the y-intercept is -1. You also need to know what that means in terms of the graph, of course. So in this case, the y-intercept is going through -1 on the y-axis and the gradient is 2, which means that for every 1 we go across to the right, we go 2 up. Okay, so the formula for a gradient is rise over run, so the gradient from there is 2. Okay, that's simple. So I'm sure all of us have seen that equation before for the equation of a line, a straight line, and we'll also talk about the equation of a line in standard form, which looks a little bit different. It is important to understand that every point on that line is a solution to that equation. So if we substitute x equals 4 into that equation, we get y equals 7. So 4, 7 is a point that lies on the line, and that's how we can tell if a point lies on the line. So every point on that line is a solution to that equation. You may need to find out the equation of a straight line when you're given the gradient and the coordinates of the point on the line. So for example, we want, what's the equation of the line? Gradient 2 passing through that point, -1, 3. So I know the equation of the line is y equals mx plus c, and in this case I know the y value, that's 3, I know the x value, that's -1, and I know the gradient, m here, is 2. So if I substitute everything in there, that allows me to solve for c, and now I know that the value of c is 5. So the equation is y equals 2x plus 5. And there's the graph. If we don't know the gradient of the line, we need to find 2 points on the line. So just recalling a little bit about gradient. Gradient is rise over run. So in this case here, the gradient is 4 over 2. Okay, so if we have 2 points on a line like that, we can easily work out how far we've gone across. In this case, from an x value of 0 to an x value of 2, so 2 across, and we've gone from an x value of -1 up to 3, so the rise is 4. So the gradient always rise over run. In general, the formula for gradient is that, but I prefer to just write out the points and actually work it out each time rather than use the formula. So, what's the gradient of the straight line joining those points? I would definitely draw a diagram for this rather than use the formula. Even though this is showing us using the formula, I would much prefer to draw a diagram here, which is, I think, a more visual thing. So the gradient here, in this case here, is 2. Okay, so if we want to find the equation of the line through those 2 points, first we need to find the gradient. So 2, -3 and -1, 3. I can see the run is we've gone from -1 across to 2, so the bottom line is going to be 3, and we've gone from -3 to 3 to -3. So it looks like we've gone down 6. So in this case here, the gradient is -2. Now we have the gradient, we can substitute in what we know. So I know it's -2x plus c. I've got 2 points on the line. I can use either one of those to put in here for y and x. So if I choose 2, -3, I replace the x with 2, y with -3, gives me c equals 1, and that's the equation of the line, -2x plus 1. Sometimes we want to rearrange the equation of the line so it's not in this y equals mx plus c form. So if we rearrange it and just get everything on one side equal to 0, this is called standard form. So let's look at this example here. This is a standard form of a line, and we might want to rearrange it so that we get the gradient. So if we rearrange it, leave the 3y on the left, subtract 4x from both sides and subtract 7 from both sides, gives us this step here, and then divide everything by -3, gives us this. If we cancel those negatives, I can see clearly the number in front of the x now is 4 over 3. So that's the gradient, 4 over 3, and the y-intercept would be 7 over 3. Parallel and perpendicular lines. Obviously, if 2 lines are parallel, their gradient is the same. if they're perpendicular, one gradient is the negative reciprocal of the other. That's important. So if we want the equation of the line parallel to that line which passes through that point, we know the equation of the line is y equals 2x plus c, because we know the gradient's the same. If it passes through the point -1, -3, again we just substitute -1 here and -3 here. And that gives us c equals -1, and therefore we've got the equation of the line, y equals 2x minus 1. If we now want the equation of the line that's perpendicular to that line passing through that point, we first have to think what is the gradient of the line that is perpendicular to that. Remember that if two lines are perpendicular, the gradients are the negative reciprocal. So here, reciprocal just means turn upside down, so go from 2 to a half and it's negative, so it's negative a half. We then say, if we know the gradient now is negative a half, we've got an x value, 1, we've got a y value, 4, substitute that in, and gives us c equals 9 over 2 or 4.5. We can then write the equation, negative a half x plus 9 over 2. Normally we don't like to leave the equations of lines like this, so if we multiply everything by 2, we get that, and then put everything over to one side, we now get the equation of the line in what we call standard form. One other idea that the syllabus mentions is the word direct variation. So I just want to quickly explain what that means. Direct variation is where as one variable increases, the other variable increases. So if I've got a relationship here between x and y, this graph here would show us that x varies directly with y. There's direct variation going on here. So you might have something like the number of items on here that are for sale, and here along the top would be the cost, the total cost of the items. That would often be an example of direct variation. Now it doesn't matter what the slope is, so this one here is also an example of of direct variation, even though the slope is different. So we're starting from 0, 0 and we're going off at different angles. So these here are all examples of direct variation. How this links into the equation of a straight line is the equation here is always going to be y equals k times x. Okay. Now that value of k may change, as I've shown you in these different examples, but that will mean you've got direct variation. If you have something like this, which is definitely a straight line but is starting somewhere up here on the y-axis, this is not an example of direct variation. Or if you've got something that's doing something like this, that's also not an example of direct variation. So we're only limited down to a very few small examples of lines that look like y equals kx.